Hello and welcome. Thank you for joining us today for this webinar hosted by ZEPHIR, Zero Energy and Passivhaus Association of Turkey, titled Green Transformation. Are we ready to retrofit existing buildings? The opportunity to retrofit apartments and office buildings with passive house standards. In this important session, we will explore the necessity of green transformation and the potential for applying greenhouse standards to existing buildings. We are especially honored to welcome Dr. Francesco Nesi, the founder and scientific director of ZEPHIR Passivhaus Italia, and a doctor of physics, who will share his valuable insights with us. Dr. Nesi is a leading expert who has pioneered several projects in the field in various countries. First, I would like to gather your thoughts through a quick poll. Let's reflect on whether we are truly ready to retrofit existing buildings to meet the passive house standards. The results of this poll will help guide our discussion in the coming minutes. Please take a moment to respond to the poll appearing on your screen, and we'll continue with the webinar shortly after. Once again, welcome and thank you for your participation. Dear guests, I would like to hand the floor over to President of Board of Zero Energy and Passive House Association, Ms. Seda Güleç, for her welcome speech.
Hello, everyone. To be in front of you today is of great pleasure. We're very happy, and we have a very precious guest today, and he will be with us on the. He will be talking about, and he will be sharing with us his experience. And I am Sepev, and the head of the director, and I'm the chief head of the board of our association, Zero Energy and Passive House Association. And we have a presentation here, and we will then afterwards, I'll be giving the floor to distinguished speakers, and I will be giving the floor to Dr. Nesi and Passive House Institute. And we're, in fact, Passive House Institute was established with Mr. Volkan, and in 1996. And in fact, it's working as an institution, and it was founded in 2012. And it's providing a lot of support to the suppliers, scientists, and those parties who are working on passive house. All the stakeholders were then giving information to the global level, and they are still. And this is an association. It undertakes the task of working platform for architects, engineers, practitioners, academics, students on passive house standards and zero energy buildings. And our association was founded in 2012, and we're providing seminars, conferences, and we're an independent and non-profit organization that aims to be pioneer in the spread of and trying to disseminate zero energy buildings in our country. And we're trying to disseminate this. And we are doing our best, and we're doing our best to make this known. And what is passive house? And this is, once we ask the question, once we take a look at the standard construction standard in our country, Turkey. Regardless of climate or geographical location, passive houses then remain at a comfortable temperature year-round with a minimal energy input. It's a standard, and there are 5 main criteria, in fact. And in Turkey, in Republic of Turkey, there are 2 certified buildings in Turkey. One of them is now a new building in Gaziantep, and it's an ecological building in Gaziantep, so it's certified PH in Turkey. And the other one is the improvement of, in fact, Dr. Francesco will speak about this, how current building is improved so that it's turned into a passive house. It will receive its certificate, and it will be the first in Turkey and also in the world. So it is a restaurant and in Şile, of Şile district of Istanbul, and the construction of which is about to be completed, and it has undergone the tests, and soon it will receive its certificate of being passive house. And we hope that these projects will be it will be much more wider. And I'd like to thank you once again for your kind presence here with us today, for your cordial presence here with us today. I wouldn't like to take much more time of yours, but I would like to give the floor back to Ms. Yasemin. Thank you.
Thank you so much, Seda, for this great introduction. Dear guests, please do not forget to answer our survey. It is appearing at the scene, and you can see at the QA part 2. And also, we have a section under the screen where you can select between English and Turkish. So please select the language you would like to listen the webinar from now on. Now, I would like to share with you the short biography of Dr. Nesi. Dr. Nesi is a building physicist, certifier, trainer, and certified passive house designer. After studying physics in Italy and Germany, he specialized in building physics during a post-doctorate in Austria, directly in contact with the creator of the passive house standard, Doctor of Physics, Wolfgang Feist. Since 2011, he has directed ZEPHIR Passivhaus Italia, coordinating as scientific director its activities in Italy and abroad, carrying out in collaboration with private individuals, professionals, companies, local and government institutes, as well as numerous European projects. Over the last 15 years, he has met tens and thousands of people at sector events, teaching them how to design and realize the highest quality of living. Author of the bestseller Passive House, the Italian reference manual on passive buildings, published by Maggioli, he has been and continues to be a speaker at hundreds of national and international conferences. And tonight we are very distinguished to have him with us. And Francesco, the floor is yours now.
Thank you, Yasemin. Do we already have the results of the poll?
So let's quickly check. Perhaps we will see any results, because I have seen that there are some results around. Perhaps our guests are still answering the survey. So let's see. Yes, we have some results now. Can I share them with you, Francesco?
Yes, yes, we are seeing it. Yes.
Yes. So the question is, which are the most critical issues that can be encountered during a construction process? So 75% of our guests have answered as non-skilled designers and trade persons when dealing with the construction. And 25% of our guests have answered as delayed delivery of the building.
Yes. Good afternoon, everybody. Thank you for this nice invitation to ZEPHIR I'm director of ZEPHIR, which means Zero Energy and Passivhaus Institute for Research. So very a name very close to ZEPHIR, to the ZEPHIR one. Actually, I wanted to start with this poll just to fix some ideas. Usually, Italy and Turkey under several aspects are very similar. Indeed, we are a seismic country like you. The property is owned mainly by individuals. We have a lot of condos also in Italy which need to be retrofitted and so on. And we lack of expertise, for instance, among the designers as well as among the tradespersons who need to do the job on the building site. And you will see in my presentation how this can be improved. On the other hand, according to your answers, one of the most critical aspects you may encounter during the construction process is a delayed delivery of the building, which reflects in a lack of preliminary design, integrated design among professionals. This is also very interesting and very important when you are approaching a low energy building like a passive house. So I want now to share with you my presentation. I hope you see it. The title is Green Transition. Are you ready for retrofitting existing buildings, as Europe is asking us? Let's present the opportunities offered by Passivhaus for retrofitting and renovating flats, offices, besides buildings and neighborhoods. So let's start this presentation with some concepts which were already introduced by Seda before me. Just to remind that our approach is basically our approach for an NZEB, so for a nearly zero energy building, or for a ZEB, like Europe is now promoting and fostering, which means zero emission building, is indeed for us Passivhaus. What does it mean? So the 5 pillars, the 5 basic principles were already mentioned by Seda before me, but let's look them more in detail. So first of all, Passivhaus is based on the concept of non-consumption. So we should not consume energy. So first of all, we should save kilowatt hours and not compensating them through the installation of renewables, because still our building remains leaky, and this is not a sustainable approach. So first of all, I should keep the heat inside the building, which means we should invest on a good thermal insulation around, which wraps up the whole building envelope. Windows are another very important component in order to bring the heat inside the building. Because by doing this, by letting the sun go into the building during the winter time, we can save energy, thus heating up the building for free through the sun and through the persons who live in the house, as well as the electronic device and everything which is households and so on, which are present inside the building. But which kind of window should we install in the Turkish climate? Of course, in Turkey, you also have lots of different climatic conditions, and the choice of the right window also depend on the peculiar climatic situation. I would say, for instance, in Italy, we install triple glazing with thermal brick-free frames in the northern part of Italy and double glazed windows in the southern part of Italy, like I would say in Turkey, more or less. Then we should see every specific project by itself, but let's put it generally, as well as selective glazing in the warmest regions of Italy, like Calabria and Sicily, like the hottest part of Turkey, let's say. This to speak in general, but then we should really design properly, appropriately for each location where the project is located. And then thermal bridge-free design. A thermal bridge is a weak point, let's say, in the thermal envelope. It's where the heat during the winter season can flow towards outside with no interruption. And of course, we would like to have a continuous layer of thermal insulation, as continuous as possible, which wrap up our building. And we should therefore design and try to solve as far as possible all thermal bridges. Because this can also bring the heat in summer from outside to inside, thus increasing the cooling load and therefore the costs also for cooling down the building during the summertime. Another very important concept is the air tightness. Air tightness is basically absence or almost absence of air leakages in the building envelope. This prevents also that a huge humidity flux flows through the building assemblies, through the walls, through the roof, and so on, because at a certain point you will get condensation for sure. And if this happens on the load-bearing structure, that may in the end lead to even structural problems. That's why when you are addressing a low energy building, you should definitely invest and take a lot of care about air tightness. And in such a building, of course, we should change the air in order to get fresh air for hygienic reasons. And you could do it in two ways, either by manually opening the windows. But if you do this during the winter time, you will lose a lot of energy through the windows in an uncontrolled way. And if you do this in summer, you will get a lot of heat coming into the building, which you should get rid of afterwards through the mechanical buildings, which get rid of the overheating. That means the best way to do this is through a ventilation system, a ventilation unit with heat recovery, which recovers up to 90–95% of the outcoming of the heat from the outcoming air, giving it to the fresh air which goes into the building. That's very simple indeed. And there's not so much technology, but the ones I just spoke about. Nowadays, we can count more than 3 million square meters built with this Passivhaus standard worldwide. Most of them are also monitored. And as you can see here, we have the monitoring of the very first Passivhaus, which was built in 1991, close to Frankfurt in continental Europe, let's say in Germany, which shows that year by year, the Passivhaus building doesn't feel what's happening outside. Basically, you can have a colder year, a warmer year, or some tenants may leave their windows tilted open for the whole heating period. The Passivhaus basically doesn't see it on a statistical average. And that means that we are speaking right now about a very robust approach and very cost-effective one. And this holds also for retrofits, which is the topic we are going to speak today, as well as for units. And we are among the pioneers who explored this new possibility and finally got the very first certification as an Retrofit unit. And here below on the right side, you see PHI issuing us the certificate for the very first Retrofit, which I'm going to talk afterwards in my presentation. This is in Italy, in Bergamo. But let's keep on speaking about Passivhaus first. So how easy is it? Is it very complicated? How much energy do I need to heat it up, to keep it warm in the worst day of the year? We can assume then that the most you need is lighting up 35 tea candles, and you have heated up your building in the worst day of the year, or a hair dryer, or a cow, or you could even invite your friends for dinner, and you can get heat for free given by the persons. Of course, you should compare in your mind whether you can pay for a dinner to your friends, or you just prefer to light on 35 candles. But this is just for fun. But this is just to fix some ideas about how easy a Passivhaus design is. Indeed, as already mentioned by Seda, Passivhaus works for all climates, and this is our small contribution in the world. So we have been designing and working in several countries, just exploring the most challenging climatic conditions like tropical or subtropical and so on, like Cameroon. We were in Bhutan, an Himalayan country close to India, and Dubai. We have designed a museum in New Delhi, and we are also working in Canada, for instance, for the certification of a skyscraper. So very important for us is to get to know a multitude of climatic conditions in order for us to increase our expertise in designing and supporting designers all around the world for specific projects. So a question which is always made us by clients is basically, but does Passivhaus really pay back? And how to address this topic towards a client. So back to 2017, we published a paper, preliminary paper about the economic convenience of Passivhaus standard in energy retrofits in Mediterranean climate, where we explored the possibility to retrofit them up to the national minimum regulation or to the Passivhaus standard. And it came out that Passivhaus indeed pays back immediately, already from the first year. And this was furthermore verified several years ago. So this is an update of 2023, so last year, where we collected a lot of projects. Here I'm just showing some of them, located in several different climatic conditions with different building typologies, either wood or masonry or concrete plus thermal insulation and so on, and with different treated floor area. As you can see here, here they are listed by growing treated floor area. You can see here very easily that the additional costs, so the blue bar, is indeed always lower than the total savings you get already from the first year. So this means for all projects we investigated, we managed through the building physics, through our Passivhaus approach, to bring them at an extent, at a level that for the client is immediately clear that they should invest on Passivhaus right now. And if we want to calculate the net present value of all these projects as an average, we get a free budget, let's say, of 14,000 euros, which means we can demonstrate economically and analytically that Passivhaus pays back, in fact, through the savings during the operation. Passivhaus adapts not only to a large bunch of climates, but also to several different kind of urbanistic situations, such as neighborhoods. Here I'm going to briefly speak about this project called Symphonia, led by two cities in the Alps, so Innsbruck in Austria and Bolzano in Italy, with the aim of retrofitting more than 100,000 square meters buildings with, let's say, an Enerfit or Enerfit-like concept, let's say, so the Passivhaus approach for the retrofits, thus saving at least 50% of the primary energy and increasing the renewables by 20%. These are, for instance, the demonstration sites in Bolzano, so a lot of multifamily buildings, as well as public buildings, and the same holds for Innsbruck. Passivhaus also adapts to multifamily and non-residential buildings. Here you can see, for instance, an office building in Frankfurt, or the Puzzle Museum in Ravensburg. You know Ravensburger, exactly. This is the museum for the puzzle, which is indeed a Passivhaus retrofit, or Heidelberg Fire Station. Also, as you can see, very different typologies of buildings, or residential buildings, very large ones, or even supermarket in Bahnstadt. At Bahnstadt in Heidelberg. It's very interesting what they did. So they just collected the free heat released by the fridges and so on, and they just used it to compensate and to heat the supermarket up during the winter time. So nothing strange, but just using physics and using the reason. Or even swimming pools. These are examples, a couple of examples which were done in Germany. Or a hospital, the very first pilot project in Frankfurt, a very challenging building and very nice project. You can find also a lot of description and reports in the internet about this. In Austria, also residential buildings. This is the Lodenareal Quartier, 361 dwelling units, more than 33,000 square meters treated floor area. Or in Austria, again, for instance, the Raiffeisenbank headquarters. Also a very nice sign for the community if a bank wants to realize a building according to the Passivhaus standard. In Italy, this is our contribution. So we built and built a hotel at the Garda Lake, or a ground school in Collecchio, or a multi-family building in Putignano, in Bari, let's say, so a latitude close to yours in Turkey, or in Pergine Valsugana in Trentino on the Alps, here where we live. We retrofitted a very big church community center, thus also showing the cost effectiveness of a Passivhaus approach. In Spain, you can see also in other kind of countries similar to ours, office building or residential skyscraper high-rise building. In Boston, in the US, this is the biggest office building in the world. And this is also a very nice project which was also presented this year at the International Passivhaus Conference in Innsbruck, a retrofit of an ex-Pirelli building, so an industrial facility which was retrofitted with passive house approach to become a boutique hotel in New Haven. In Italy, we also have a lot of single-family houses, and I wanted just to mention a few of them, just to mention and to remind that every kind of building typology is indeed possible. Let's say from residential, so masonry construction building, or concrete plus thermal insulation, or residential done in CLT, so cross-laminated timber, construction with external thermal insulation, or even in straw bales close to Bergamo, close to the place where we did our Retrofit unit. And there we come, exactly. The very first worldwide Retrofit units, one for flat done by us, and another one for offices designed and realized by Home Grid. So the Portugal affiliate in Aveiro, in Iliavo. So this is the office retrofit. I'm just starting by the project done by them, and then I'll come to the project we followed directly. So the office retrofit is located in Iliavo. These are some energy-related data. So 52 square meter treated floor area, typical mechanical services of the mid-90s with 2 electric radiators, which is very common in Portugal. No insulation at all on walls or ceilings, and basic aluminum frame with single glazing. This is the situation they found in 2014. And after some years, they decided to retrofit it for several reasons. First of all, they paid so much for electricity, which was indeed the needed for heating up the office, and they paid like more or less like a rent. So at the time in 2018, the average office rental in Iliavo was about €5 per square meter a month, and they paid roughly the same. So a second rent, they decided, no, come on, here we must retrofit it. Besides this, they had a very uncomfortable situation. They monitored, they measured the average temperature, the ambient temperature. They didn't come even higher than 16 degrees as internal temperature in winter. And the ventilation, they had no mechanical ventilation at the time, and they only ventilate through window openings, thus losing a lot of energy. So this is the architectural concept. They intervene from the inside, of course. Here is the staircase, and here at the right-hand side and down, they have other offices as well, as you see on the left. So, of course, they had to intervene, as said, from the interior, and they applied on the external walls 6 centimeters XPS. They did the same for the roof, and 2 centimeters XPS to the floor. And they decided to leave the existing windows there and installing on the outside new PVC windows with the UF, usual for this kind of climate, like around 1,3, double glazing, a small G factor, sort of selective glazing with warm edge spacer. New mechanical services were also installed. So a ventilation system came in place, as you can see, with a very, very low annual electricity cost, roughly €35 a year. And for heating and cooling, they decided to install 2 kilowatt split unit by Daikin Premium Plus. And electricity production afterwards was also installed on the roof, 4 PV panels giving producing 1 kilowatt peak power. The blower door test after the intervention showed a very good results, around 0.6. And these are the final component characteristics reported on the certificate. So these are typical values for external wall, exterior wall in Portugal, windows 1.2 on the average, glazing, G value. As you can see, Portugal is a very happy climate, and they even don't have any requirement, for instance, on the glazing, on the maximum solar load, on the ventilation requirement. Of course, they got a 0.68 for the air tightness and a very low PER demand, primary energy demand, around 56. Just to have a close look to the PHPP results before the intervention, by assuming, like in the reality, that the neighboring offices are not heated, so they are really suffering a lot of discomfort because they are not going to heat them during the winter. Of course, you have a lot more of thermal losses through the neighbors. And in this situation, from the actual situation in 2014 to the situation after the intervention, they save even 75% of the energy. And if one assumes that the neighboring offices are indeed heated, which is not the reality, but just for in theory, they would have got an 80% reduction. So let's say between 75 and 80% reduction on the overall energy, which is indeed a great result. They are also monitoring the office costs, and as you can see, they are also monitoring the energy production by the photovoltaics, thus compensating it, compensating the energy consumption, and coming to a negative daily energy balance. So they are getting more energy than needed. And the PE, the primary energy demand, is very, very similar to what was designed before the construction. Let's come to the apartment retrofit in Bergamo, Italy, which we followed directly. So the owner is an architect, and he wanted to use his project as a showcase to demonstrate that passive house retrofit is indeed feasible. And the motivation is that we have an existing building stock which is composed by basically 93% of let's say dwelling units which are individually owned. So it's very, very difficult to retrofit a multifamily building, because most of the times this will never belong to just one person who can decide for the retrofit, but we should agree among all the tenants what to do, and we will never come to an end. And that's why it's very important that we wanted to demonstrate the possibility to retrofit just one dwelling unit. We had several financial schemes. I also see in the chat that someone is asking this, called super bonus. So after the COVID, we got a lot of money from the EU, which the government decided to invest for retrofitting buildings and dwelling units. And but as you can see, since 2020, people didn't use this money to come to the highest possible energy level, as one could argue and could think about, but just reaching the lowest ever energy classes. So this big amount of money didn't indeed produce a significant energy reduction for the Italian sector, let's say, and just 1 or 2% of the energy performance certificates are listing buildings in class A, so the maximum, so which is very bad situation. And we can say that even though we are the country of the sun, as one always says, still we are consuming so much for heating up our houses, and we can estimate that this is around 67% of the heating consumption coming only from the building sector. Another motivation for the owner, for the client, was was due to the very bad air quality in the Po Valley. As you can see also from the literature or from the internet, the Po Valley is a very flat valley, which is very highly polluted from Milan to the Adriatic coast, and the need for fresh air quality was in fact a good motivation, a good stimulus for the client to proceed with the passive house approach. So the objectives, first of all, cost effectiveness and feasibility of Retrofit for single flats pilot case. So we wanted to show this. We wanted to implement bottom-up regeneration actions in line with the European Green Deal, and to realize a short construction supply chains engaging not experienced but still motivated local manufacturers and workers, and thus creating a replicable model offering economic feasibility and design scalability, and finding out innovative retrofit solutions compatible with limited intervention, as it happens in multifamily buildings. And interior thermal insulation was indeed a major challenge, because this would have increased the risk for interstitial condensations and mold formation. Another big issue to overcome was to create a seamless airtight layer and thermal bridges mitigation. So an ambitious task, also because we had architectural and structural constraints. Due to a very big traffic downstairs in the neighboring street, we couldn't install external scaffolding, and that's why we had to be very quick in doing all the works. And also the engagement of a workforce unfamiliar and untrained with such a high standard was also a major issue, which we will see in a moment. And we had to train them really on the building site. This is where the project is located. So here, not so far from the city center in Bergamo, this is the big building. So just one dwelling unit in a multifamily building of 120 dwelling units. And of course, due to the constraints, we had limited solar gains. As you can see here, the only two exterior walls are facing north and west. And at the western side, as you can see, there are also very big surrounding and high surrounding buildings, which also produce shading on our building, on our dwelling unit, on our flat. So this is the architectural concept after the renovation. Here you can see a couple of balconies, which were then also used for installing the air conditioning outside. And the walls were done by wall cavity, so 2 layers of brick and with a gap of air layer in between. So we decided to remove the internal shell, let's say, by installing some insulation on the interior. This is how it looks like. So for the building physics, as a building physicist, we should also have had this slide, of course. So this is the thermal envelope, and these are the boundary conditions. So these these walls are facing outside, so to outdoor ambient. Here they are towards a neighbor. That's why we are not losing energy through these walls. And partially we are losing energy through the staircase, so to one unheated ambient. Regarding thermal bridges, we already mentioned, and now I want to share with you the issues we have to face during a retrofit by intervening only from the interior. As you can see here, as said already, we removed the interior brick shell by installing a lot of insulation here with vapor barrier. Of course, if we install insulation in the interior, not only we have to provide a continuous layer of air tightness, but also provide a vapor barrier in order for our building assembly not experiencing any mold formation or internal condensation. We used a very high thermal resistant material, which is polyurethane, directly in contact with the outside layer of bricks. And in the service cavity, we installed mineral wool. Then we have concrete pillars in between, and they were wrapped up by vacuum insulation panels with a very, very low thermal conductivity, thus not taking out any centimeter more of living space to the interior. So this was also one of the goals we wanted to reach. The rainwater downpipe was also installed inside the insulation layer. And as you can see here from thermal bridge calculation, everything is very well realized, and the minimum interior surface temperature is pretty high, thus giving a lot of more comfort to the occupants. By installing, by intervening from the interior on the sole flat, it may happen that we are not heating up for free the neighboring apartments, thus putting them in a very bad situation in terms of mold formation, because maybe it may happen that their surface temperature is decreased at a point that mold creates and form on the outer, on the perimeteral building assemblies. That's why we also realized 3D thermal bridges in order to understand this issue, and we wanted to verify this before intervening, before starting the construction. So here you can see a vertical section through a French window towards the balcony. Here in the center is our flat, and here upper and below we have the neighboring apartments. Before the intervention, the interior surface temperature, minimum temperature, were totally in the area of mold formation or even condensation. And after the intervention, as you can see, a new roller shutter box was installed, very well insulated, triple glazing instead of single or double glazing with air in the gap between the glazings, and some lateral insulation done by calcium silicate panel was also put here in order to increase the surface temperature. And you can see that on the other hand, the minimum surface temperatures of the neighboring apartments didn't vary so much from before, because we had 9 something and 12 something, and afterwards 9 something and 10 something. So it was bad before and is still bad afterwards. So it didn't create any major issue to the neighbors. So if they have mold, it's their fault and not ours. This is very important also to prove to the neighbors, also from a juristic point of view. For the construction phase after the intervention, a good care was also taken to the realization of the airtight layer at the joint with the intermediate ceiling, and as well as to the reveals of the windows or at the seal of the French windows. And nevertheless, even though we trained all the workforce used at the building site, they made a sort of disaster, because as you can see here, there are a lot of cracks in the airtight layer, and the result of the blower door test was totally unsatisfactory, being larger than 1,6. And we were striving less than 1, let's say, at least. Of course, this is due to the workforce unfamiliar with air tightness, but also with the bad choice of the membranes done by the owner. Then we train them, we explain them again, and they redo everything by scratch through the necessary improvements, as you can see, and also by the right use of tapings everywhere, we could come to the desired result. So 0,77 calculated with the ISO 9972 and rescaled with the very old 13829, it is still below 1. So we were very satisfied in the end. And concerning the mechanical ventilation, we decided to install a compact unit, which is basically a heat pump connected to a ventilation system. And this is how it looks like, the distribution. So this is the supply air, a very compact distribution, also by taking into account a very small amount of false ceilings in order also for the client to save money. This is the extract air, which is very compact indeed. And this is the distribution of the outdoor air, fresh air, purified by smoke, fog, and so on, and pollens, and so on. And on the other hand, this is the distribution of the exhaust air. So everything very, very compact. And parallel to this, we decided to install recirculation units for heating and cooling in the same space we already used where we installed false ceiling for the distribution of the supply air and this extract recirculation air. These are the energy performance of the final building. As you can see, the final flat, as you can see, the exterior walls show a smaller value or smaller U values compared to the office in Portugal, because Bergamo is located close to the Alps in the northern part of Italy. And windows also are less than 1, and glazing are done in such a way that we try to maximize as much as possible the solar gains during winter. And air tightness is less than 1, ventilation, heat recovery, and PER demand. So these are some pictures of the construction works. Here, first of all, everything was demolished inside, and after removing the internal brick shell, this is what is left outside. So only 10 centimeters brick, and then we installed the internal insulating materials and so on and so forth, as I already showed you. The realization of the airtight layer, closing everything with gypsum board and so on. And this guy is performing the balancing of the ventilation system. And this is how it looks like, the installation of the ventilation and the split units in the false ceilings. And this is how it looks like in the end. So nobody could argue, could say that this is a passive house or is not a passive house indeed, but it was also proven by thermographic image, and you can really notice the huge difference with respect to the neighboring apartments from outside or from the inside. As you can see here, there are small pieces which may only due to some shading in the thermographic camera, so everything is perfect. And we are also monitoring through some data logger that we installed and realized and installed as a pilot project in this very flat. And we are monitoring not only the comfort parameters such as temperature, relative humidity, and CO2 levels, which always stay limited, let's say, during the whole days, but also the money spent from the beginning, which correspond to €2 a day for everything, for the whole energy consumed by the building. So sort of the cost of a cappuccino in Italy as well, let's say. And the lesson learned is that we managed to create a replicable and scalable model. We found out effective and affordable solution to retrofit the post-war real estate sector. So we could, after making a real comparison between a normal retrofit and the retrofit according to the passive house principle, we could really find out that there are no significant additional costs compared to a regular retrofit up to the minimum required by law, which are the NZEP buildings. At the moment, around 1,300 to 1,400 euros per square meter. So they are really comparable. We see a wide potential after realizing this very first NFIT unit certification for the retrofit of the existing building stock. There are still some criteria to be fully defined. For instance, we are still speaking with PHI about the criteria for air tightness and so on. So more pilot projects are needed. And indeed, we got the second one in Salerno. After showing some client what we did, he decided to sign the contract and to proceed with the second NFIT flat. So in the, let's say, Mediterranean, more Mediterranean area, similar to what you have, as you can see here, very similar to the first one. But if you think about your building stock, it's really viable and you have very similar situations in Turkey. So further steps for all of you attending this seminar, this webinar, is training, for instance, to get the designer certificate or to be certified as a passive house tradespersons. There you can go to the ZEPHIR website to inform yourself and participate, engage yourself, because it's very important to have workforce familiar with this concept whenever you have to do a passive house project or not, but you think another way after the courses, and possible support and consultancy also from our side to go in support of an existing architect or designer who you could have, or to produce, to analyze, let's say, from the economical point of view, several solutions, several variants, and so on, or certification. So certification activity, I'm of the 30, 40, let's say, certifiers in the world, acting worldwide, as well as some people from ZEPHIR. So you can do this also with them, as well as certifying components such as building systems or building components like windows, rollers, shutters, box, and so on. So I want to say teşekkür ederim, and we are open for any question from your side. Thank you for being attentive and still there until now.
Dear Francesco, thank you so much for all these invaluable insights for the passive houses. And we hope that now many people are more eager to join us and follow us with the journey in our passive house buildings. There are very many questions. I have been going through the questions, and of course, during your presentation, you have been answering some of them. So I would like to make a selection so we can cover the utmost on the passive house standards, as we have time only until 8:30, which means we have 28 more minutes with you. So I would like to first ask on my behalf a question, and it is related to working with the PHPP, because what we have been experiencing with most our students is that after they get the certification, they are a bit they need courage to start working with the PHPP. And once they start, of course, then many people start practicing. So, especially with the thermal bridges, do you have any practical suggestions for entering thermal bridge data in the first trials in PHPP before starting going into deep calculations?
Is it a question for me or for Cedar?
Of course.
For me. No, actually, during the courses I gave, always designers are asking me at what extent we should insert into PHPP things in the beginning, like should I input domestic hot water if I really don't know anything about the distribution of mechanical services or something like this, or thermal bridges. Regarding thermal bridges, in the preliminary approach, we never calculate them, but we just estimate them and put into PHPP. But especially in our climates, for instance, yeah, in the southern part of Italy, but also in the northern part, where also cooling is important, I really do suggest to input at least a preliminary assumption hypothesis of the distribution of domestic hot water, because this affects dramatically the cooling demand and the cooling load. So even though I know you have already finished the PHPP when you come to the domestic hot water worksheet, but that's life. So if we want to preliminary design it well, you should either see not only heating but also cooling. And that's why this also helps you in reducing, for instance, some, I don't know, thermal insulation towards the ground, because it was too thick in the beginning, and by reducing it, you can get rid of some overheating during summer, while increasing a little bit, just a little bit, the heating demand, but the cooling demand will dramatically decrease. So there are some strategies which can be implemented, and therefore my suggestion would be really to go as straightforward as possible to the end of PHPP. Of course, primary energy, we never see it in the beginning, but at least the distribution of mechanical services, I think this is very important to fill in before going on with the design.
Sure. So you suggest that we take care of the domestic hot water distribution for sure, and we can play with the insulation at the ground floor, special, which is touching the ground. So those are very straightforward answers for us.
Yeah.
One of our guests, Esra Aydınoğlu, has a question, and she would like you to share the name of the shopping center which uses the heat of refrigerators.
If I'm not wrong, they should belong to the firma REWE. So REWE. You can look into internet for this. If I'm not wrong, it should really be this, the pioneer. But after this, I guess some other have been built up to the passive house level. So basically, it was also located in a place. This is a nice story. So the municipality decided to demolish and rebuild everything. They decided in such an area, all buildings should be rebuilt as passive house. And then somebody came from the supermarkets, and say, we want to establish there. Okay, it should be passive house. No, at all. Come on. Okay, out of this area. Okay, then we can explore the possibility to go with the retrofit, with the new construction according to the passive house level. And this was a very pilot project, which helped also PHI to define some things like the problems of coming in and out from the supermarket, and because then it was accounted for some extra ventilation, not only ventilation losses, but also ventilation air change rate, let's say, you know, in positive. So they introduced also new ideas also for everybody.
It's a very interesting project for sure, Francesco. We have a question from one of our guests, Cihangir Yıldız, who is a civil engineer. And we know that the passive house standards are mainly based on extreme energy efficiency standards. But he's asking, isn't it important to take into account the embodied energy and carbon footprint values of the materials, insulation materials like XPS or rock wool, used to ensure the thermal insulation standards? He's asking this question considering the new European Union Green Deal and all the upcoming agreements.
Yeah, like zero emission buildings, which I was referring before. Actually, in principle, not. Because in the original version of Passive House, it was developed in 1981 by Wolfgang Feist. And at the time, he realized that if somebody, so there's a problem with energy supply, there's a problem with climate change and so on. So everything which can be made to save energy and to save fossil fuels goes in the right direction. And that's why Wolfgang Feist in the beginning explored the very first projects with timber frame constructions and so on, but not only, also concrete, also with limestone and other kind of materials, as well as for by using PVC windows, let's say. Of course, PVC windows include polyvinyl chlorures or chlor, which affects the let's say the sea, the water, and by its production is against, so it's making fishes die and so on if you release it to the water directly. But anyway, on the other hand, if anybody wants to use them, he didn't want to force them not to use them, because of course they are more affordable compared to wood plus aluminum frame, like, I don't know, 1/3 or 1/4 cheaper than another frame. But if it makes passive house affordable for somebody, that was really the goal in the beginning. Nowadays, that the European directive is going towards this, there have already been some discussions among us, also with us stakeholders, let's say from every country, about how to introduce some LCA, let's say, factors, parameters in PHPP, as well as how to address the acidification potential and everything else, so glowing warming potential and so on, which are normally addressed by, for instance, by other building standards such as LEED, for instance, which you may know better than passive house. But these kind of parameters were never introduced into this PHPP, also because there was no availability of third-party independent results about the LCA and so on, which made the treatment very difficult to be made. But nowadays there's a European project which is called Outfit, which is recently released the possibility to join to link PHPP with this external worksheet in order to investigate the LCA, the global warming potential, and so on, of a lot of materials used in PHPP, and therefore addressing exactly what the civil engineer is asking for. So as you can see, there have been some history which have been used to create, build, renovate up to 3 million square meters according to this building standard, thus saving a lot of energy, whatever material used, whatever component used. And now that we are tending to go towards zero emission buildings, of course, this becomes more important. And you can really get this very nice tool, LCA tool, for free, made available by PHI, I think, on their website, or on Passipedia you can find it. We already used it, and we are exploring it since a couple of weeks. Very nice.
Thank you so much. That's a very good input for us again. Now we have a question from dear Seda. Italy is an earthquake zone like Turkey, and Italy has very many cultural heritage buildings. So taking these two aspects into consideration, what is the demand for energy efficient retrofitting for these cultural heritage buildings, especially on the earthquake zone? How can you combine these two parameters?
Actually, it's not an easy task, let's say. But on the other hand, we have a lot of building stock, existing building stock, which needs to be renovated. And I would really start from them, as well as from the public buildings, as a showcase for the citizens. On the other hand, I don't want to refuse replying to the answers, but on the other hand, conversely, I want to say something. So from the one side, our countries are very similar, so we face similar issues, for instance, regarding the ground floor, so the joint between floor slab and external wall. How to realize a continuous layer, insulation layer there? You can never realize a continuous insulation there, forget it. In Germany, they do it because they cut the very first brick, let's say, they put the so-called Kimmstein, so a thermal break-free brick, which connects to the internal insulation, thermal insulation, and connects directly to the external insulation system. But this is forbidden by our civil engineers because of structural problems. By luck, it is forbidden, I say. And that's why we have to use another approach. So we will insulate from the inside. Of course, if we are speaking about renovating, we cannot go under foundations. Of course, we intervene from the warm side, from interior on the floor slab, and on the other side, on the wall, we should, as much as possible, go down with the external insulation in order to minimize the thermal bridge of this joint. On the other hand, it's not important that we realize the thermal bridge-free, completely thermal bridge-free building, but that we minimize the thermal losses. As you can remind from the CPHD course, or from whatever other energy course you have followed in your life, professional life, important is psi value times L times length times, let's say, delta T, delta temperature. If the outside temperature is very high, because in winter our average temperature is relatively high, not as low as in Germany or as in the Northern Europe, then the delta T is smaller, and you can also have a larger psi. And these all things combined together produce a contribution which is basically similar to what happens maybe in Germany, or even lower. So don't stress yourself too much about how to solve thermal bridge, let's say. So we should definitely do this, but don't be fanatic in trying to solve them. Important is that their contribution is minimized, and that's very important. And this has been done by calculating them, estimating them, proposing solutions, discussing the solutions with the building construction company, because maybe a solution costs too much in the realization, and we have to speak all together, not only in an integrated design among professionals, but also together with the construction company. I see also Cihan is, I think he agrees, right?
Yes, thanks so much. That's quite relieving because sometimes people can get quite annoyed with the thermal bridge calculations and how to do. And in fact, in practice, it's quite straightforward, as you say.
Yeah.
We have a question about three-dimensional concrete printed buildings. So, is it possible to achieve a passive house standard with three-dimensional concrete printed buildings?
Yes, actually, we realized so the first passive house in concrete in the Marche region, not through a 3D printer, as you suggest, but we already demonstrated that it works. So by using the same strategies that we use there to realize a concrete building with thermal insulation layer, of course, on the outside, we already explored this possibility within a public tender in Dubai. We were attending. Unfortunately, we didn't win because they were only giving prices to architects, let's say, and not to the energy part. But nevertheless, this gave us the opportunity to explore these 3D concrete printers, and we indeed designed them perfectly. So there are no problems. There are some problems about the gaps, how to fill in the gaps, because they are not perfectly straight when installing some external insulation, but we could somehow, with some external finishing, we can, before installing the thermal insulation system, we can render them perfectly straight, and then installing the outer shell of the thermal insulation system. So from my point of view, it's also promising technology. The only thing is that they consume a lot of water, and this secondary topic, but still very important for us, should be also investigated more when addressing 3D printers, let's say, in my opinion.
Now I would like to share with you a question on the financing mechanism for renovations of existing buildings in energy efficient manner. So is there any fund or contribution or a mechanism introduced by the government for the building occupants, for the residents? And this is, we don't have a name, but this question comes from someone who's working in the public sector. So your answer is very valuable.
Thank you. Yes, I read it in the chat, and I tried to already answer it during my presentation. But of course, it's very important to recall it again, to stress the importance of this for policymakers. Actually, don't do the same errors we did in Italy for this absurd financing scheme called super bonus, when they gave from 2020 on 110% of the costs done for a renovation to anybody, just by going up to by two energy classes. But as said, they were unclassified and then just reached the class F or class E, which is still worse. And nothing changed basically, but the problem connected to this kind of financing scheme is that this was in principle, very nice because it gave a big push to the economy, to the building sector. But on the other hand, it was only gotten by those who were not interested in investing them for energy efficiency, but just because they were for free. And if on the other hand, we put financing schemes and financing, so incentives, something like, I don't know, up to 70, 80%, and the 20% you have to put yourself, by yourself, only people who are really motivated will go for a renovation. So this is really by heart my my invitation not to do this. Nowadays in Italy, we have 70% of the interventions of the overall, let's say, expenses done within a renovation, which can be deducted from the yearly, from the taxation you should pay yearly. So indeed, it is also not for everybody, but only for those who have to pay a lot of taxes. That's why it's still for rich people and not for everybody. In my opinion, it should be done another way according to the energy level reached. So you pay enough taxes, this small amount of taxes if you reach higher energy levels, whereas if you don't invest enough, you pay more. That would really give a big push towards the right direction. But we know how is Italy, and friends of friends of friends should get the money, and that's not easy task, let's say, to motivate policymakers at the government level. Moreover, our government changes every half a year, so we will never get a continuous approach, because then the next government will release them, then they will be introduced again, but with a lot of new rules. And for us designers, it's really crazy how to follow all these things, and the result of all these kind of incentives is that nowadays our building sector is completely down, completely blocked. So nobody is investing anymore in renewing, in retrofitting, or in building new constructions. It's really a bad situation nowadays. I hope so we can do our best, but still we also see a decrease in our economy. So incentives are important, but also not. Let's say it was even better before COVID, before giving all these incentives, because people, the motivated people, really invested in the retrofit of their houses and so on. Especially now that prices, energy prices are so high, we should definitely invest right now on the retrofit.
That was very interesting, but I believe this is the case in very many countries, what you are experiencing, but you are experiencing it ahead of many countries. So I hope that people would get some lessons learned from your case, of course. Following this answer, I would like to ask you this question. What is the acceptable minimum energy consumption in the energy performance certificates in Italy? So you are discussing about just pushing the limits a few levels high, but what is the minimum energy consumption acceptable in Italy now?
As you know, we are a very peculiar country, so we don't have a minimum compared to all other European countries. We have
So you don't have a national regulation?
Yeah, we do have a definition of NZEB, but it's very complicated and very silly. For instance, we refer to a hypothetic reference building with certain U values for the windows, for the walls, and so on. And then the calculation is made on the overall conductance, let's say, on the overall thermal losses of the reference building. And then your real actual building should not consume more than the reference building, which means you could even not intervene on some building assemblies, no thermal insulation. Then from the other side, I just install polyurethane or VIP panels or whatever in order to compensate. Overall, I'm smaller than, I consume less than the referent building. So it's very strange. Let's say in the paper we published in 2017 and then on, also going on with our research, we could find out that we took a sample building, a reference building, and we tried to put it virtually in several climatic zones in order to address the possibility to bring it up to the NZEB level or to the Passivhaus level, no? As I already mentioned in my presentation. So I can mention how high the NZEB level is with respect to the normal, let's say, retrofit or normal construction. And what I can say is that in the north, the difference in the heating demand between our definition of NZEB is so high compared to Passivhaus that the Passivhaus wins immediately. In the southern part of Italy, cooling and heating are more or less equal. So cooling is larger, let's say, is larger than heating, and but prices are lower. That's why for the materials, for the components, for the craftsmen and so on, that's why Passivhaus is also comparable. In the middle part, central Italy, it's very difficult to convince people to go for a Passivhaus, and that's why in our activity we have a lot of buildings in the south and in the north, but in the center we don't have almost any, because the definition of the NZEB is already very high. So that's a good way of promoting Passivhaus as, oh, come on, you are already there, it's very close. But on the other hand, no many people will go for an NZEB in the center of Italy, and therefore it's pretty difficult. So we can have an NZEB less than 80 under some conditions, less than 30 in other conditions, and it's very weird. And I gotta, this strange definition makes also gives also very strange results. For instance, if you keep the building as it is, and you only want to change the lights with LED, you lose one class. You don't get one class, you lose one class in the energy, let's say, how do you say, Energieausweis, in the energy verification sheet, let's say. Which is very weird because the equivalent reference building has a very low energy, and you consume maybe more than the reference building and you lose one class, even though you reduced by the half the overall consumption. So it's very silly, and that's why this is creating a lot of problems also in the buying and selling of dwellings. If you go to the portals in looking for them, everybody looks for a class A, but this means nothing, and that's very difficult to convince people know how to read the energy performance contracts, let's say.
That was really interesting to hear from you. And we have so many questions, but it's already 8:30. I would like to share one more question with you, because right now we had discussed this in Austria. So we had made a presentation as Zero Energy and Passivhaus Association that we are part of a very nice, very ambitious EU project with WRI and DGGN. And we are working on some case studies also. So here's a question. Do you have a document including sketches and explanations that shows us step by step what you did while renovating a building according to Passivhaus standards? And if you have it, is it possible to share with us? So If that's the case, of course, we would love to discuss that with you, and we would love to include it for our case studies in our e-modules. So I'm taking that question on behalf of Zero Energy and Passive House Association.
Actually, not, unfortunately. So the presentation I gave you is one of the most accurate ever that has been done so far in Italy regarding retrofits. We will for sure produce much more details and much more accurate information and photographs and details about what we've done so far, and it will be my pleasure to share it with you as soon as we get something interesting, more interesting, let's say, than only photographs or, let's say, sketches and drawings.
Thank you so much, and that we are going to remind you during our works for the case studies. And I would like to share some messages. We have message from Lebanon. Recently we have certified 2 mechanical engineers from Lebanon, and we have certified passive house designers from Lebanon with us. So they thank you for all this very informative session. Joe Asmar from Lebanon has written. And also one of our corporate members, Cihangir Yıldız, he expresses his gratitude to Zero Energy and Passive House Association Management and to you, Francesco, for all this valuable time you have spent with us. Unfortunately, I have to stop here. It's pity. We would love to continue with you, but perhaps in the future we will have another session with you, if that's fine with you also, Francesco.
Why not? It would be a pleasure for me. It's always a pleasure for me to keep our collaboration active from both sides. So thank you for inviting me. As you always, it's always a pleasure. We have to share. We need to share our respective experiences. And thank you to everybody also for listening to me, for the nice words, and to you especially for the organization, great organization, for the interpreter and everybody else.
Yes, and I would like to thank our guests for being with us until this time, and to our both the organizer of the event and our interpreter, Pınar also. This is from us for the moment, and we'll be in 1 month's time, we will come up with another webinar, hopefully. And thank you so much.
Thank you to you. Bye-bye.